Hello class, welcome to business statistics. In this lecture I will talk about confidence interval for mu, which is population mean. So this is population mean using t-stat or t-statistics. So in our previous lecture, we kind of talked about confidence interval for mu using z statistics or z score. So one of the primary questions in this is when to use z and when to use t. So z is usually z stat is used when sigma, which is population standard deviation, so this is population standard deviation is known. So at the same time, when this is known, you will have n, or the sample size, greater than or equal to 30. So that is when you will be using z. And now when to use t stat, you will have sigma is unknown and n is less than 30. So when we say sigma is unknown, that means we don't know population standard deviation. So population standard deviation is not known. So instead of sigma, we replace it by s, which is sample standard deviation. So that's how that's the condition under which t-stat is used. So again, the confidence interval for mu formula mu, when we use z stat, you remember this is the formula which we wrote: x bar minus plus or minus z alpha over 2 sigma by root n. So now the confidence interval for mu when we use t-stat is, it would be the same, x bar minus plus, now instead of z we will write t alpha over 2, and then we will introduce a new term which is called degree of freedom, and then s by root n. So instead of sigma here we are using s. So this is degree of freedom. So it's represented by df. So usually both the curves, if you see normal distribution, z score, this is how it looks. Even the t-stat, so this is t-stat, it looks the same, but the tail would be much more fatter. Since we don't have population data and we are dealing with sample, the spread is very high. So that's the reason why it looks like a normal, but the spread changes. So here the degree of freedom, the formula is n minus 1. So if we have a sample size of 20, the degree of freedom will be 19. So if we have a sample size of 10, so if n is 10, then degree of freedom will be 10 minus 1, 9. So the degree of freedom formula is n minus 1. So what the significance of this is, so if you see, this might be of degree of freedom 2. If you see the degree of freedom, something like if we have a degree of freedom 5, the curve ends will be start becoming thinner. So this will be with degree of freedom 5, say, and when we reach degree of freedom 30, it kind of start looking like a normal, exactly like a normal distribution. So this is degree of freedom 30. So usually the degree of freedom tells you about how the curve will look. So that is the significance of degree of freedom. So again I will write the formula. This is T stat, and then we have confidence interval for mu. So this is used when sigma is unknown. So when I say standard deviation, it might also be variance, both standard deviation as well as, so they are both same, right? They both represent the spread, and then n is less than 30. So the formula for confidence interval would be x bar minus plus T alpha over 2 degree of freedom, again this is n minus 1 s over root n. So this is the formula you need to remember. So where again x bar is sample mean, so this T alpha over 2 degree of freedom, this is this is critical value, and then this whole thing is called margin of error, and then our S is sample standard deviation, and then N is sample size. So let's talk about this critical value at this time. So how do we calculate this critical value right? So how do we calculate this? So suppose if I wanted to calculate critical value when confidence interval is 80% and the sample size is 10. So when we say sample size, this represents small n. So small n is equal to 10. So we are trying to calculate critical value, which is T alpha over 2 n minus 1. So instead of degree of freedom, now I'm writing directly n minus 1. So when I say so this now I need to calculate alpha over 2 first. So to calculate that, they gave us 80% confidence interval. This means 1 minus 0.80, that is 0.20, is my alpha. So alpha over 2 would be 0.10. So that's alpha over 2, and then I have n minus 1. So my n is 10. So degree of freedom is n minus 1. So this will be 10 minus 1, that is 9. So this is again the t-stat looks something like this, and our z table, in our statistical table we discussed that it gives left of the curve. So our t table, we have a t table also, which I will show you how to read. So this will give right of the curve. So again, this is would be, so I said 80% confidence interval, that means this is minus t and this is plus t, and then this whole area is 0.80. That means this area plus this area together would be 0.20. So this area will be half of it, that's 0.10, that is alpha over 2, and this value would be alpha over 2, which is equivalent to 0.10. So now when we see our t table, it's going to give this area. So it's not going to, like in z used to give us the left of the curve, which is something this side, but now our t is going to give right of the curve, which is this one, this whole area. So that means because the curve is anyway symmetrical, so if I get this value, that the negative value of that t would be this value. So that's how we are going to interpret it. So at this time I am looking at our alpha over 2 is 0.10 and our degree of freedom is 9. So I will kind of write this what value we are looking for, that is t. Let me write in different color. So this is, I'm looking for okay, so this is, I'm looking for t alpha over 2 n minus 1. So this is t 0.10, n minus 1 is 9. So this is the value I am looking for in my t table. So to get that value, I go to my to canvas and go to modules and go to module 0, calculation aids, and then go to statistical tables, So download statistical tables and then open it. I do enable editing and then I'm looking for T table. So here is my T table. So if you see this, so the degree of freedom is column A. So column A is degree of freedom, and then this T point 40.25, that's alpha. So that is what you are kind of doing, and this is your degree of freedom. So let's see our T value. So T alpha is in our problem. If you see, it's let me change the color. So T 0.10 and the degree of freedom is 9. So I go to T 0.10, so that is this value, and then degree of freedom is 9, so I go this way, so that is this value 1.3830. so that's so this value is 1.3830. so this minus T is, so this value is mostly the positive side, so that is 1.3830. so this will be minus 1.3830. so let's do another problem. So this is I'm looking for a critical value at critical value with confidence interval maybe 90%, and then sample size n is maybe 20. So now the critical value, again the formula would be T alpha over 2 n minus 1. so this is I wanted to calculate alpha over 2, so 90% confidence interval is given, so I would do 1 minus 0.90, that is my alpha, so alpha would be 0.10, alpha over 2 is 0.05. so if you draw the curve, this is 0.90, and then this area and this area together would be 0.10, so this would be alpha over 2, which is 0.05, and this would be alpha over 2, 0.05. so again this is what we are going to get, and then we can automatically do minus P alpha over 2 n minus 1. So alpha over 2 I got the value which is 0.05. now n minus 1 is, my n is 20 minus 1, this is 19, this is my degree of freedom. So I'm looking for a value T 0.05 comma 19. So this is kind of, I have to again go to t table. I go to my t table and look for t.05. so let me cross check again. This is t.05 19. So I go to the t table. T.05 is this one, and then degree of freedom 19 is this one, so our value would be 1.7291. so I go here, this is 1.7291 negative, and this will be positive 1.7291. so usually your t table is giving you this value. If you put negative, it will give you this value. So that is how you are going to do t values. So now we will kind of solve a confidence interval problem and see if we can understand that problem or not. So again, I will like our previous uh, uh, lecture, I will take a thrash bag example. So this is a thrash manufacturing company. So and the manager claims, so the manager claims that its breaking strength, so I will just write mu is 39 pounds. So this is the breaking strength of a thrash bag. Breaking strength, whenever someone claims like a manager, it's always related to population. Breaking strength of the thrash bag. So you wanted to check whether manager's claim is right or wrong. Again, this is exactly 39. That is what manager is kind of claiming. So you take a, so you are trying to verify, so you take a sample. So you are taking a sample of suppose 25. Again, these are all given, and then x bar is 40. Your sample standard deviation is 10. So this is sample standard deviation. And the confidence interval is given as 90%. So they are asking you to determine 90% confidence interval. That means 90. What is the range among which 90% of your thrash bags will weigh? So they won't break until between those areas, between those lower limit and upper limit. So our formula for confidence interval for, so this is confidence interval for mu, since we have a sample size less than 30, and because S is given, sample standard deviation, that means sigma is unknown. So the confidence interval for mu, so because of these two conditions we are kind of applying t stat. So the formula is for confidence interval for mu is x bar minus plus T alpha over 2 n minus 1 s over root n. So you know our x bar is given, which is 40. S is given, so that is 10. Sample size is given, that is 25. And now this critical value we wanted to determine, this is what, so this is where we need to spend some time. So again, to calculate alpha, they gave us confidence intervals. So confidence interval is 90%, so our alpha is 1 minus 0.90, that is 0.10. So I wanted alpha over 2, so that is alpha over 2 is half of 0.10, that is 0.05. So this part is 0.05, and then n minus 1 is our degree of freedom, so n minus 1, so that would be 25 minus 1, which is 24. So this is 25 minus 1, that's 24. So if you see, if I plot this curve again, this would be minus T alpha over 2 n minus 1, and this would be T alpha over 2 n minus 1. So this would be T 0.05 and 24 is this point. So it's going to give me this area. So when I go to the table and look for it, so I will go to the table and look for T 0.05 and 24. So here is my table. T 0.05, again that's this value, and 24 is here. So T 0.05 and 24 would be this value, 1.7109. so I will go to this. This will be 1.7109, so this will be negative 1.7109. so that is what I got. So now again, we need to calculate this confidence interval. So I go here, confidence interval for mu, so this will be, so the lower limit or lower bound would be x bar minus T alpha over 2 n minus 1 s by root n. So this will be equal to, so our x bar is 40 minus T alpha over so T alpha over 2 n minus 1 would be this value, that is 1.7109 multiplied by s is given as 10 over square root of 25. So this value you will get 36.5782. Again, upper limit we'll calculate x bar plus T alpha over 2 n minus 1, this is comma, s over root n. So if you see, this is comma, just to avoid any confusion, this is comma, just okay. So x bar is 40 plus 1.7109, s is 10 over root 25, so this is going to give us 43.8. 4218. So that means our breaking strength, so the lower breaking strength is, so the best case scenario, when you like worst case scenario, when you see 36.5782. So a bag, one of the bags out of those uh, 25 samples, so these 25, one of the bags will break at 36.5782, and the other bag will break at the best case would be 43.4218. So the manager claimed that the claim of the manager was 39 lbs, so pounds. So this is 39. So when you see the manager's value, if it lies between these two, that means his claim is true. So the manager's claim is true, that it will be approximately 40, exactly 40. So because of this range, and the manager's value lies within this range, the claim is true. So that's how you kind of solve this problem. So now I will kind of use this same problem and solve it using calculation aids. So I will copy this values. So the given is n is equal to 25. So this is given, n is equal to 25, and then x bar is 40, s is 10, confidence interval, I think it is, let me check, 90%. So this is all given. So I will go to our calculation aids. So again I will go to module 0. So this is modules. I will go to modules, module 0, go to calculation aids, and I will download chapter 9 calculation aids. And then open it. So this is what you will look at. So again, which sheet to use is the important thing here. So once you go here, you know this is kind of n is less than 30 and sigma is unknown, so that is unknown variance. So unknown variance, so variance is not known. So you go to the sheet which is confidence interval unknown variance. So this is the sheet you will be using, and then our kind of, if you go to the problem, the first thing I wanted to know is sample mean. So I will go to the question and see what is my sample mean. X bar is 40, so the sample mean is 40. So this is 40. So I go here and then type 40 here. Okay, so this is 40 and then I go here. This is sample standard deviation, so that would be let me check what is the sample standard deviation. Sample standard deviation is 10, so I will go to the Excel sheet and type in here 10, and then alpha. I need alpha value, so I go to this, and to get alpha they gave us 90% confidence interval, so you do 1 minus 0.90, which is 0.10 is your alpha. So you key in alpha is 0.10. So this is 0.10, and the sample size, I need to see what is the sample size. The sample size should be 25. So the sample size given is 25, so I go here and do 25, so that is 25, and hit enter. So if you see, I got these values 36.57, and then that is my lower bound, and then my upper bound is 43.42, and my critical value is 1.7108. so that is so if you see, this is my critical value, this is my margin of error, this is my lower bound, and then this is my upper bound. So that's my answers. Those are my answers. Okay, so we will try to solve one Hawk's problem on this and see whether we are able to do it. So I will go here, and then I will open Hawk's. So let me log into Hawk's. Okay, so let me see if this is T-stat. Yeah, so this is a T-stat problem. So we have 20 random selected refrigerators, and a sample mean is 57.22, and a standard deviation is 25.76. so this is, they didn't say population, they said sample. So they took a sample of 20 refrigerators, and the sample mean is 57.22, and then standard deviation is 25.76, and they wanted us to determine 90% confidence interval. So the first question is to determine critical value. Let me note down these values in our Word document. So this is Hawk's problem. So we wanted n, so the n is the sample size they gave us is 20 randomly selected refrigerators. So n will be 20, and then the next thing is 50 sample mean is 57.22. So the sample mean is 57.22. So x bar is 57.22, and then the sample standard deviation is 25.76. Let me go. Sample standard deviation is 25.76 and 90% confidence interval. So let me check if it is 90%. Yeah. So the first question is they're asking us to calculate the critical value. So what is the critical value? So critical value, again, it is T alpha over 2 n minus 1. So we can just key in these numbers and see what is our critical value into our calculation aids. So I go to chapter 9 calculation aids, and the sample mean is let me delete these all. Maybe I will close this. I need to undo this. Let me download a new document with okay. So okay, I will delete this, and then our what's that, our x bar is 57.22. so that is our x bar. This is our x bar. So I will go and type in here 57.22. so this is 57.22, and then this is I think it should be 25.76. let me cross check. Okay, so this is 25.76. that's a sample standard deviation. 25.76, and then 90% confidence interval. So they are looking at 90% confidence interval. So alpha would be 1 minus 0.90. So that is 0.10. So I will type in 0.10. So this is 0.10. This is same. So now I wanted n value. So our n value is 20. So I will go and make changes. So this is 20. So this should be 20, and I will hit Okay, so the answer is the critical value is 1.7291. So I will type in that. So the critical value is 1.7291. So this would be 1.7291. Hit enter. How about next problem? We'll see. So they are asking us 90% confidence interval for the same problem. So lower endpoint and upper endpoint. So I will calculate. I will go and check lower endpoint. So lower endpoint is 47.26. 47.26, and the upper endpoint is let me cross check. Upper endpoint is 67.18. So this would be 67.18. and submit it. So that's how you are going to solve t-stat values. Again, there is I will kind of close this document and again open a new one. So again I will be downloading the new calculation aids of chapter 9. And if you see, we have our third spreadsheet, that is confidence interval, unknown variance, data. This is also a t-stat. So that's a t-value, but now you will be asked to enter the data and determine certain values. So let's check these some problems on these in Hawk's Learning. So let me check whether I can find some problems in Hawk's Learning on this. Okay, so this is the question. So now we have our data, and if you see the data is we have how many data points? 19.73, 16.09, 15.27, 17.19, 21.72. So those are 5 data points. So they wanted us to calculate 98% confidence interval. So I will copy this data and then go and paste it here in my Excel. Okay, so this is, I will key in those numbers. So that is 19.73. So this is 19.73, and then the next value will be 16.09. The next value is 15.27. The next value is 17.19, and the next value is 21.72. So that's what we got. Our sample uh, size is 5, so you got 5 here, so if you check this, it's 5. So the system will randomly calculate for you how many sample, what is the sample size when you key in. So alpha, so let me check the question for alpha. So they said 98% confidence interval. So this is 98% confidence interval, so that means alpha would be 0.02. so 98% confidence interval, so this would be 1 minus 0.98, that is 0.02. so this is 98. So this would be my alpha value. So I go here and then go to the calculation aid and type in 0.02, hit enter. So they are asking us, so the first question to solve this kind of problem is calculate the sample mean. So I go here and look for sample mean, so that is point estimate of sample mean. So this is okay, let me check what is that value. Okay, so that is I will highlight it, that is 18. So I go here to Hawk's learning and this is 18. So that's good. How about the next one? Calculate the sample standard deviations. So you go to calculation aids and then look for sample standard deviation, which is 2.673. so I will go here and type in 2.673. So 2.673. So you can they said 2 decimals, I'm just typing in, it will take it, especially for me, because I can set it up for my system. And then find the critical value. So I can go and look for critical value. So the critical value here is 3.747, 7469, that is 747. So 3.747. And then they're asking us lower endpoint and upper endpoints. So I will again go and check lower endpoint. So lower endpoint, I can copy this and then paste it here. Okay, I think it's not able to paste it here. I'll just type in the value maybe. So 13.52 is my lower bound or lower limit. So 13.52. So that's 13.52, and my upper limit would be 22.48. So that would be 22.48. So I submitted. So that's how you will be solving T-stat problems. I hope this lecture made sense. Thank you.